Hi everyone and welcome to today's ODI lunchtime lecture. My name's Freya. I'm one of the producers working with the ODI on these events. Today I'm very happy to welcome Claire Fram and Gala Camacho from Diagonal to give today's talk. They're going to be talking about using fragmented open data in the built environment. I would really love it if you could submit some questions with the chat function during the talk. I can read them out once the presentation has finished or invite you to unmute and read them out yourself, whatever you're most comfortable with. But if you could keep your cameras off and your mics muted whilst the presentation is actually in progress, that would be appreciated. And you've probably noticed that we're recording the event just now. That's just so that we can post it to the ODI's YouTube and SoundCloud accounts afterwards. So if you want to review anything that we've discussed in the talk today, you can just go there later this afternoon where you'll find the talk. So that's all from me just now. Thank you very much, Claire and Gala, over to you.
Great, thanks Freya. I'll share my screen. Let's see. Great. Is that sharing the correct screen?
No, you're sharing your notes.
My notes. Okay, let's try it again.
Yes, perfect.
Okay, great. Okay. So today, as Freya said, we're going to be talking about the use of data in the built environment and can we be using it in any better way. First, we'll do intros to explain who we are.
Yeah, I'm Gala. I am a data scientist at Diagonal. My background is in math, and I have worked across different parts of kind of civil infrastructure and products in kind of civic tech. And I guess I'm part of Diagonal because I really think that cities could be better and more equal. And so I want to use my skills to do that. On to you, Claire.
Great. I'm Claire, product manager and part of the founding team of Diagonal along with Gala and Andrew and Simona, who are not speaking today, but maybe on the call. And I have a background in information science, and I've been working on R&D projects in the built environment and the transport planning space for the past few years. And I'm really interested in how we use open data and inclusive technologies for urban design. And we're thrilled to speak with you today. So thank you for taking some time to talk with us. I'm gonna give you a little bit more background about what Diagonal is, who we are, before we jump into the challenge that we want to discuss today. So at Diagonal, we're building tools to analyze and visualize data to unlock creativity and progress around better decisions in the built environment. And in doing so, we really care about how we deliver our work, and we work to uphold the right to the city. And we approach projects with openness and transparency. So we're technologists, but we're inspired by cities, and we believe that we need to bring responsibility to the work that we do. And towards that, a little bit more about us is that we're a steward-owned company. And so that means we have a guardian chair that locks control within the company, and it legally binds us to be transparent about our work, the purpose of our projects, our funding, and that we uphold the Universal Declaration of Human Rights. Happy to talk more about that, but just wanted to drop it in here as well. But today we want to talk about the challenge of how do we affect change in the built environment, and how do we make use of the data that we have in the built environment. The conversation that we're having today, we're kind of setting out in 4 parts. So first, we will set out our understanding of the world today and the premise that actually we have a lot of open data. Then we'll talk about the challenges that we see in this space, making use of the data that we have. Then we'll go on to how we're approaching that challenge and describe some case studies to make that tangible, and then everything else. So technology, we think, is one part of affecting change, but we recognize that it is only a small part. So the initial premise, there is a lot of data that describes the built environment. There's traditional sources like census data, there's OpenStreetMap, which many people are familiar with. There's a lot of newer data sources about mobility, micromobility, live traffic counters, ridership. Cities and public authorities, as well as citizens, are making more data available through open data portals using common standards and APIs to publish data. So we think that there actually is a lot of data about the built environment that exists, and more is being added all the time. So why don't we all have, a perfect digital twin, kind of trigger warning, sorry, if we have so much data available to us already. And we think that one of the reasons why we're not able to make the most of open data is because connecting all of that data together in a meaningful way is just hard. It's hard because there are inconsistent relationships. So the census may release data in one boundary area type. Your transport authority may use a different boundary type. Connecting those can just be time consuming. There's differences in data types. So what I mean is you've got roads that you need to somehow connect to buildings. You've got transit schedules that need to be connected back to networks. There's just a lot of data that might not fully connect up with each other the way that we see, real transport city systems, land use systems actually exist in the real world. And that when you start to add all these pieces together, you end up with something that can be really heavy, a really big, we're talking big data here. So for anybody playing, buzzword bingo, we've got digital twin and we've got big data. You can check that off your board. But okay, so let's zoom out a little bit. Do we care about connecting all these data sources up together? So what? And at Diagonal, we think that it would be really helpful if we were able to connect these sources up so that we could understand city systems, right? So what if we were able to better analyze and understand, for example, health outcomes related to environmental factors? So health consequences related to exposure of poor air quality. That right there involves understanding of a few different city systems together, in the built environment, but also your community kind of demographic information about health. And some of that can be quite sensitive as well. What if we could use citizen sensors to inform policy? There are a whole bunch of reasons why citizen sensors right now may not be used to their fullest potential. And we think that some of the kind of initial steps around assessing kind of context for sensors could be addressed differently. And another example of city systems that we think would be helpful to understand are things around, 15-minute cities. So in the built environment, there's a very popular understanding of the benefits of having multiple kind of a basket of amenity types available to individuals within a 15-minute walking radius, maybe 30-minute walking radius, 30-minute city, because access to those sorts of amenities might lead to better outcomes, right? Access to good jobs means better outcomes around employment, access to good healthcare, better health outcomes, education, and so on. When we talk about a 15-minute city, 15 minutes for who, or 30 minutes for who? What if we could actually understand the way that mobility for individuals might actually change what people have access to. So these are some of kind of the bigger questions that we think understanding city systems will help us address. And just kind of a few examples. And so what are we doing in this space? So that's the challenge, and that's why we think it's important to make use of open data in these spaces and reach the potential. What are we doing about it? So we at Diagonal are building new tools. We know that the world is not made up of individual layers, which is the way lots of traditional geographic and geospatial information systems typically represent the world. Rather, the world is connected. It's a bunch of interconnected systems. So we're building a data model from the ground up that we think looks more like the world. And I'm going to now walk through what this looks like technically in some detail, and then we'll zoom out again, so not to worry. So we're building a semantic model of the world, and that means we have a single connected model of data that represents the world, and that connects roads to buildings. Transport schedule data can be connected to networks. And buildings can hold properties related to things like administrative boundaries and so on. So that's kind of part of our core principle in our technology. But then we are making the most of this connected model of the world and have designed it in a way that we can ask questions in a more intuitive way and get answers faster. So the actual structure of our connected world model is highly memory efficient, and it enables geographic search and network traversal using parallel processing methods in ways that traditional GISs don't. And lastly, the interface with this data model follows common patterns. So we're backed by cloud compute, and we can expand also the way that we interface with our world model based on need. So that's kind of some description of the technical underpinning of what we're building. But as I said, we're going to zoom out again, and I'll hand it over to Gala, who's going to share some examples about what have I been talking about.
Thanks, Claire. Yeah, so I guess part of our building of new tools has been to use them ourselves to, well, kind of understand, like, are these actually useful? Is this actually what we should be doing? But also to be able to kind of highlight what is important and how it changes the game a bit. So can you go to the next slide, Claire, please? Okay, so we started with the 15-minute city, if nothing else, because that is like such a common undertaking that lots of different local governments are doing, not just here, but across the world. So I guess just going to run really quickly through what this picture on the right is saying, and the current process, which is you have some data about the city. In particular, we were looking at kind of the buildings around the city and then restaurants. And so you have this data that tells you where restaurants are, and you want to understand, well, where are the hotspots of these restaurants? Where are they missing? And so if, you could do the same thing for health, or you could do the same thing for education. But, we chose restaurants to start just playing around with this problem. And so this starts with some data that you start with. You then go into the computation, which is take every single building that you see here or in an entire city, and then see how many restaurants can it reach if it walks 1 kilometer, and then you get these results. And so the way this usually works, maybe in a local council, is that they define these amenities they want to look for. Then the GIS team or maybe an external party goes and does this computation, which tends to take a very long time, even days, one could say, and then reports back the results, and then policy changes or decisions about what they're going to build or not build. And so I guess what we're arguing is well, could this be better? And we argue, yes, it can definitely be done better. And in particular, it doesn't have to be so siloed. It doesn't have to be so compartmentalized. It doesn't have to be define this thing and then go compute it and then now make decisions. Actually, what it could be is it could be a loop. And one of the things you need in order for that loop to even be feasible is speed. And so different from other GIS systems, if we want to do this computation where we want to understand if for every single building in London, if people walk out of their front door, how many restaurants can they reach in this 1 kilometer? If we can compute that in, let's say, 15 to 20 minutes, then, well, what does that do for us? And actually, it unlocks a lot, because now, well, you could, for example, redefine your definition. You could maybe do that in a community consultation, where usually you would enter a room, get them to define what things they want to access, and then go and compute it and then present results. You could actually do it in the room. You could actually in the morning define, in the mid-morning be seeing the results, and then in the early afternoon be redefining those places, because actually once people got to investigate the results that came out, they actually realized that they maybe want to change some bits or make them kind of meet their needs a little bit better. And so this speed ability, this ability to have speed, gives you so much power into making this process interactive and bringing people on board that are usually not part of the process. And so kind of in that, we have the ability to interrogate. And that basically says is you shouldn't have to be this hyphen data person in order to interrogate the data and to question and to have a say on the gives and takes of different algorithms and different models. And the only way you can do that is if you have a platform to do that in that is not defined by the person doing the analysis. And I guess iteration is the other thing I talked about. It's really hard to conceive of a problem from scratch and get it right. And so if you do not have the right technology to let you make mistakes and come around, then you kind of run the risk of your entire definition of the problem being wrong and then having no way to backtrack. And I think we've seen that in a lot of different parts of city making, where decisions were taken and then there's no way to go back because the analysis was already done. So yeah, this map here just shows every building in an area of London, and it tells you the redder it looks, the more access to restaurants that each of those buildings has. Okay, and then a completely different case study. So this is actually part of a research project, and we're only a tiny part of the beginning, where there's some climate science researchers who I think this is a well-known thing, but you have official weather stations, and then people in their backyards put little sensors, and they actually are not a weather station per se, but they actually collect a lot of weather information. And these two maps here show the Netherlands on the left and the right. And one has the official weather stations and one has the citizen weather stations, which are these sensors put in when people put sensors somewhere in their property. And it's clear that there's many more of them. And because there's many more of them, then if you use them to predict weather, it would be very, very useful because you would have much better weather prediction in your models. But one of the things they need to know, because different from official weather stations that are made in a very particular way, where there's nothing around them, citizen weather stations can be amongst buildings. And so one of the pieces of information that they need in their model is, well, what are the buildings around this sensor that are obstructing it? And so on the right here, you actually see what we created, which are different, which we're creating still, which are different kind of obstruction profiles, where if it looks really orange, it means it's very unobstructed. And if it just looks like a tiny little polygon, then it's probably very obstructed. And so I guess because we can just do this anywhere using OSM data, which is just out there, then what this allows is for them to kind of be able to clean the data about the sensors and then try and see if it's feasible to use them in fancy weather models. And I guess even just this week, like a huge part of Australia is like underwater, and a lot of people weren't even able to leave their house. And one of the reasons that happens is because weather models just are not reactive as quick as we need them to be. And so being able to do something like this could actually be, really impactful to places that are being highly affected by climate change. And, we can do all of this stuff just with open data if we have the right tooling. So these are two things we've done recently, and I guess they show the power of having the right tooling for the job. Next slide, Claire, please. Yeah, so I mean, we talk about tooling, but ultimately, that's only a tiny, tiny part. And I think that important for us is that we stop just kind of talking about technology as the thing that is going to give us the answer, but rather the tool as part of a tool set that is going to help give better answers and better fixes and almost better innovation. And so I think that the thing we want to talk about is like, can tools allow for more space to explore other parts of the challenge? And we think the answer is yes. Like if we don't have to be thinking about the technological challenge, we actually create a lot of space to talk about maybe much more important things. And we can ask way bigger questions. So yeah, next slide, Claire. Yeah, so I think the question we put out to you is like, what else could you do? As a data scientist, there's lots of things that I haven't been able to do simply because I've had to work, I wouldn't say alone, but maybe within the team of data scientists, and I haven't had the right tooling to interact with all the subject matter experts in the detail that I want. And so if I did, which is what we're trying to do, and are getting there, then like, what better things could I do? And I think, in my opinion, a lot. So yeah, and maybe I'll pass on to you, Claire, to discuss this question too.
Great, yeah. So I guess we'll open it out now and hopefully have a little discussion with the folks on the call to hear a little bit more about what you guys think. We've set out our understanding of the world, what we think one of the challenges is around missing the right tools to make use of the open data, how we're approaching the solution while recognizing that technology is only one small part. And so we would like to hear what you think around what's holding you back from using more open data, and what do you think the future of open data is in shaping the urban form? And also, what do you think the role of technology should be in the future of shaping our cities? That's everything from us. Thanks so much for letting us tell you a little bit about the work we've been doing.
Thank you very much, Claire and Gala, for that talk. Yeah, please, as Claire's just said, feel free to just unmute yourself and chip in at this point, especially if you have any thoughts on what is what's holding you back from using more open data. You can put something in the chat if you would rather not speak out, but just unmute yourself if you'd like to.
Hiya, it's James. I work at the planning portals. We obviously deal with a lot of sort of online planning applications, sort of the front end of development management process in England. I think one of the things we look at is, when we want to provide more sort of location specificity to users when they're using our services, is that the sort of the data available is quite patchy. We integrate with a lot of individual sort of local authorities, and they all have sort of data locked away in their systems. So if they're doing a sort of project themselves or a service themselves, they are able to tap into this data. But again, at a national level, we find it sort of difficult to access that on a sort of a level playing field. So a user could go and put any location in and know they're sort of getting the same sort of quality and quantity of information sort of provided at any given point. I guess the solution there would be some sort of standardized or government mandated provision of this information at a national level, or through a standard API, or data standard schema, etc. But obviously,
yeah, it's tricky. That we've definitely been in some of the kind of questions we've been looking at, running into challenges where data might be held by different, for example, local authorities in kind of different formats that I'm thinking of planning data and brownfield data specifically. There might be a description of what that data should look like, but actually it's pretty loose, and that can be challenging. And a lot of traditional, I guess, ways that GIS systems have been designed is, they were desktop, and now everything is migrating to the cloud. And so there's kind of a challenge in the lag, the lag time between getting data on off of people's like local computers into a way that can be shared. One of the motivations, I think, for us to build this semantic connected model of the world is that we think that there are, better ways to share and connect up data, that the intent is for it to be open, but maybe people don't know quite how to execute on that. I don't know if you want to add anything to that, Gala, or Andrew, I think, is on the call as well.
Yeah, I think maybe the thing I would add is like, where we are now, it doesn't have to be where we are later. And so I think there's like bandwagons we can jump on and like become part of. And so, for example, like, is there areas in, for example, OpenStreetMap that aren't well mapped? The answer is absolutely yes. But if you want good data, you're going to spend a bunch of money buying it, but maybe a different way to think about it that is more sustainable, and potentially, at least I believe, in the city making space, maybe better, is you could also maybe twist the direction and expend a bunch of time mapping it, and then other people will map it. And I mean, that's how the open source bandwagon works. And the point is, you kind of need to make that call, knowing that that means some other things are going to go not as great as you would expect if you bought the data. But then there's kind of this bigger purpose that you're pushing towards, which is like the more you go in that direction, the kind of easier it becomes to go in that direction later. So there is kind of this long-term investment. And the other thing is, yeah, I mean, we need systems that can take data that is locked away and in weird formats or in non-standardized, and we need good programming that lets us absorb that. But one of the biggest problems that the layered structure makes it hard is that the layer structure by design keeps things separated. And when you think about things separated, it becomes then very hard to ask questions in a way that is natural to us, because in the way that is natural to us, we understand that if I can't just, for example, move a building, but in a layer, you could just entirely move the layer and then it's in the wrong spot. When things are connected in your data models, then you can ask the question in the way that is a bit kind of more natural to you. And so taking the time and effort to bring that data into this semantic model, it's definitely time consuming and energy consuming. But once you do that, you can ask the better questions. And so maybe it's just about what time frame you're thinking about in the decisions you're taking. And I think it's painful either way. So yeah, I think it's more about where you're going, not where you're at right now.
Yeah, I love the concept of moving beyond the layers. I mean, I guess by definition, even in terms of a user interface, as soon as you've got one layer on top of another, then one's obfuscated, right? So that ability to sort of drill down beyond that, different ways of presenting it, just in terms of a user interface, let alone in terms of anything else, it really does open up a lot of potential. I guess the other side of it, in terms of talking about sort of those location specificities, we obviously use national data sets for that, but then a lot of those are point based. So where you're looking at, for example, a building or a development, you might get a grid reference point that defines where that is, but it doesn't define sort of the extent of that building and how it exists, sort of in the real world. So where do the actual boundaries of the site or the building lie? What are they adjacent to? And that's something, again, that a lot of individual authorities or individual organizations will have in their own gazetteers, but isn't easily accessible at a national level, just to infer the sort of relational data between that building and what its surroundings are.
Yeah, that's something that we've been spending some time kind of trying to resolve, even within OSM itself. Some buildings will be marked like in terms of like their use with a point, whereas others, like the whole building boundaries themselves, might be labeled. God, I don't know if you want to speak to that.
Yeah, I mean, I think it's maybe a sad realization when you realize that you're going to have to make a bunch of kind of guessing whenever you just have limited parts of data. But it is a nice realization when you realize, hey, maybe it's not ridiculous for me to ask of software that does this process, because just like you're saying this problem, like so many other different organizations are thinking of the exact same problem, even within the same exact data, because they want to use that exact data. And so can we build some generalized tooling to let you drag that in and then become part of the system? I mean, the answer is yes. Why people haven't built it? I actually think lots of people have taken different ways to do it. And I think some of the ways are good in certain in certain industries. And then, we believe that for our industry, we need one that stops thinking about layers. And so that's the way we want to bring this information in. But until all that data is open, there's always going to be this guessing part. And I actually don't think that's terrible. It's better than using no data at all. I just think it's more about, like, you have the data that's kind of limited in your view, because, for example, you only have the point data, and then you have this OSM data or other open data. And the question is, can you write some code to bring that in? The answer is probably yes, most of the times. And then how well that does is going to depend on the data set. But once you build some of those tools, new data sets tend to fit into that same or similar mold. And then the better question is, once you did bring it in, if you have a good data model and good tooling, like what questions can you ask that you couldn't ask before? And I think loads, and really great ones that lead to better city making is what I believe.
And then I guess just to build on that, one thing that we're interested in is like, so, okay, so you've solved all of your data problems, right? Because we can build tools that help us. You've thought of your really good question, you know, beyond data wrangling to something meaningful. And now you have some, you know, informed decision that maybe impacts policy or impacts, you know, design shape of the built environment. If we're doing things that are impacting the public, impacting communities, we think that there's kind of this then the cyclical component, which is, okay, how do we make that analysis and that process transparent so that members of the public can interrogate what actually went into that decision-making process? It's not just a black box, computer says, build here, for example, but that there's actually a way to follow through kind of that whole journey that that the team went on to arrive at whatever that decision is. And in part of the way we're trying to build these tools is we're making that overall data exploration journey reproducible, so that your results at the end, you can be accountable for what you come up with and share it in a open, transparent way.
Yeah, I think that's something absolutely critical for planning, development management stuff, where there is, you know, a lot of contention in why decisions are reached, etc. Yeah, it's something that's also come up in similar conversations we've had in terms of just making sure the data is trustworthy, and that, like you say, there is that transparency back through how a decision was come to, be that through an automated process or through a, you know, human decision-making process. I guess the other side of it is where such things are inferred, where we pull data in and we process it, you know, it's managing users' expectations, you know, so say, well, if you're here, we can answer this range of questions for you, whereas if you're here, well, we haven't quite got to the point where we've got the information for that. But it's also validating the stuff we're doing to them. So, you know, for example, if we're pulling in a polygon and saying, well, this is what we think your building looks like, is that right?
Yeah.
And, you know, I think crowdsourcing the quality of that data model as well.
I mean, James, I think you hit it right in the nail. Like, the point is, it's really easy to be angry whenever someone tells you they've made some decision and it's wrong, and for you at least, and etc. And so I think government has actually made heaps of progress towards trying to get people involved in the process. I mean, that's all this community consultation, but also kind of to try and do transparency. But I think that we are reaching a level where actually lots of people are very tech savvy too. And the point is, well, could we start building systems where they do get to question it? And I think that's hard as organizations, because that means that sometimes people are going to find out things that you are not doing very well. And I think a lot of organizations and institutions are very scared of that. And I think that's something that like, that's okay, but also they can get past that and do a more kind of vulnerable take on things, which is like, we are going to be wrong sometimes, but the best thing is to find out when you're wrong. And the best way to do that is to allow people to interrogate and to have opinions about the thing that you've done, and to learn a process about how to listen to that. Because I think, yeah, well, we can't always think about everything. And so involving those people, this is why I talked in that example about iteration, because ultimately you do need iteration, because it's very possible your first take was wrong. And so the more takes you can do, and the more technology enables us to do this fast iteration, kind of, I believe, the better we can design things. And so I think yeah, I think you're right there, that we need tools that let people interrogate. And I do firmly believe that the more people can interrogate, there's definitely a big layer of like, well, all these people are going to complain. And I think probably, yes, they will. But that's okay, because ultimately that's what, like, they live there. This stuff affects them. This stuff changes their everyday living experience. And it can, what we have research tells us is it can affect their health. Like these decisions we make in our computers that say, build this road or change this turn to go left, but now make it only go right, can actually like have a trickling down consequence to change someone's health or even just change someone's everyday life. And I think as such, we owe it to try and make the most transparent systems, and even if that means we're going to be called out when we're wrong sometimes. But that's how we learn, I think. And yeah, and I think the current tooling does a lot of like, here's what we did, final answer. And maybe as a previous math teacher, I know that having final answers does not necessarily mean you understood the whole process.
I suppose to build on that, you know, in the data space, like all data is, you know, has biases or is incomplete or is, yeah, only part of the picture. So the more exploration we can do kind of faster, earlier in the process, when we're forming whatever our like key question is, we think that that enables us to move forward and make better use of the data, because the data won't be able to answer everything for us. And it's important to understand also like the limitations of what the information we have to hand can be used for.
Well, thank you, Claire and Gala. That was really interesting. Has anyone got any final comments or questions before we wrap up?
If anything that we've said today like strikes a chord with anybody in terms of, you know, maybe you're working on challenges in the built environment, wrestling with data, or you just want to understand a little bit more about like actually what are we doing, we would be delighted to work with you guys. So I'll drop in an email in the chat, and yeah, don't hesitate to get in touch.
Thanks. And like I said earlier, this recording will be up on the ODI's YouTube channel probably by late this afternoon. So if you want to review anything, then you can always go back and look at it. And thanks, Claire. I see you've just put your email in the chat. Well, I just need to say thank you very much to you both for your time today, and thanks to people who've joined us as well. We've got another lunchtime lecture on the last Friday of this month in March. So just take a look on the ODI website and you can find more information about that. I'll stop the recording now, and thanks very much.
Thanks for having us.
Great, thank you very much.